Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on design of Pelton wheel. So in our last lecture, we have seen the parameters required for design of Pelton wheel. Based on that, we'll solve this problem. So the question here I've taken, a Pelton wheel is to be designed for the following specifications. So the Pelton wheel need to be designed for under this following specifications. What are the specifications are given? Shaft power is 1100 772 kilowatt, head is given 380 meter, and speed is given 750 rpm. Overall efficiency is given 86%, and J diameter is not exceed 1/6 of the wheel diameter. And to determine, we need to calculate wheel diameter, number of jets are required, and diameter of the jet. While consider here kV1 equal to, this is coefficient of velocity 0.985, and this is given the value of speed ratio. This is KUL equal to KU1 actually. This is KU1 and this is KV1. So this is 0.45. This is also called as phi, also used to consider. Anyway, these are the data are given to solve this problem. So first of all, let me write what are the data is given. Then what we need to calculate, I'll write that one. So in the first step, immediately we can write the data given in the question given. So first one we can write, this is shaft power. So SP given, shaft power is given, this is 11,772 kilowatt. And the next one is given the head. So H is given 380 meter, and the speed is given, speed N is given RPM. This is 750 RPM. And the efficiency, that is overall efficiency, is given. So overall efficiency, this is eta O, we can write this is 86%, and this one also can be written like 0.86. And next data is given, KV1, that is coefficient of velocity. We can write KV1, or we can write this CV equal to 0.985. Apart from this, also given this is KU1, or also used to call as 5 speed ratio. This is given 0.45. Apart from that, one more thing is given, that J diameter is not exceeded 1/6 of the wheel diameter. So J diameter is nothing but D equal to 1/6 of wheel diameter, or we can write this is small d by capital D equal to 1/6. So this should be considered. And what are the things we need to determine? So here we need to calculate, the first one we need to calculate, one is wheel diameter. We need to calculate wheel diameter. And the second one, we need to calculate the diameter, number of jets required. So number of jets required is somehow difficult to calculate. Number of jets required, difficult in the sense, with this data given, actually it will take some time to calculate. So this one will calculate in the last, and the last one is given diameter of the jet. So wheel diameter and diameter of jet is easy to calculate. So we'll find out first this one, diameter of jet. So these three things we need to calculate one by one. So first of all, what I'll do here, with this data given, I'll try to write down, I'll try to identify what is the wheel diameter. So wheel diameter, actually we know that this is D, and diameter of jet is small d. Okay, and number of jets required equal to, this is actually total discharge, the total discharge by the discharge of single jet. We can write this is small q. So we need to calculate Q and Q also, we need to calculate to find out this one. Anyway, so this wheel diameter we can find out from a formula of, like, U equal to, this is pi dn by 60. And here if you see, I can write this is D equal to U into 60 divided by pi into n. Now here n is given, pi value also known to us U. U is not given. So to calculate the U value, so this is the diameter. So how to find out the U, or you can write U1 or U2 equal to, we know the formula speed ratio, that is 5 into 2GH. So these things I already told in the last class how this is the formula need to be taken for to find out this one. So anyway, so this U equal to 0.45 into root over of 2 into 9.81 into H value is given 380. So from this we can calculate the U value. So let's find out this. Yeah, we'll take it to this side. So this one 2 into 9.81 into 380 and root over of this into 0.45, 38.85. So we got here 38.85. This one we got 38.85 meter per second. Now what I'll do, I'll just put this value here. So first one you can easily calculate here. This is 38.85 into 60 divided by, this is 5 into n. N equal to how much? N is given 750. So here we can calculate this one, multiply of 60 divided by bracket start pi into 750 bracket close, 0.981. So we got the value here 0.981 meter. This is our D. So first answer we got here. Okay, and the second one we can find out from this ratio itself. This is in the first one, and the second one is easy to calculate. So I'll write one thing, small d equal to 0.989 divided by 6. So we can get the second one value. So this is near about okay, better to solve in this, it will be easy for us, divided by 6, 0.1649. so we can consider this is 0.165. this is meter. Second one completed. Now the next one we need to calculate, that is the number of jets required. So number of jets required equal to the total discharge by the discharge of single jet, that we have seen in our last lecture. So to find out, yeah, this is the third one actually, this is the third one, and now here we need to find out the second one. So to calculate the second one, first of all I'll see discharge of single jet. First of all I'll see discharge of a single jet. So this can be calculated like a Q equal to, I can write this is area of jet into velocity of jet. So area of jet I can write this is pi by 4, here the d square into this is V1. So all these values we already identified here. Yeah, V1 I think we have not identified. Yeah, we need to calculate the V1 now. So to calculate this value, yeah, V1 equal to, we can identify, this is the formula is there like CV into root over of 2GH. So here also CV value is given in our question. This is 0.985 and this is root over of 2 into G into H. So actually the same formula we have used for here also, only here phi is different and here CV is different. Now anyway, let's calculate this. The value is 2 into 9.81 into H. H is how much? H is given 380. This is 380 and root over of this into 0.985, 85.05. So we can write this is 85.05, this much meter per second. So this is your V. So put the value here V. Now you can write this is pi by 4 and this is 0.165 square into this is 85.05. So we'll get the value here. Yeah, this one leave it. So what I'll do here, first I'll write 0.165 square into pi into 85.05 equal to divided by 4, 1.818. So we got here value 1.818 this much meter cube per second. This is discharge for the single jet. Okay, now we need to calculate the total discharge. Okay, so total discharge Q, we know that AV, but here it is different. Already single jet we have taken, this is V1. So how to calculate the Q value? So one more terminologies are given here. This is overall efficiency. So this one now we need to use here. Overall efficiency equal to, we know that this is shaft power by water power. Okay, so shaft power actually already given in our question, 11,772. So these values are till are not used. Water power equal to, the formula of this water power equal to rho g q h divided by 1000. So here we'll get the value of Q here. Now the same thing what I'll do here. So overall efficiency value is given. So I'll take this Q value. This 1000 will be goes up 11,000. So what I'll do here, Q, I'll write the Q here, and remaining things I'll take it to down, like 11,772 into 1000, and here denominator I'll put the value of rho equal to 1000 and G equal to 9.81, and Q already taken there. Overall efficiency how much? 86% given. So let's take this 0.86 here, and H value is 380 is given in our question. So now we can, if you solve this one, let's cancel this 1000 by 1000, and here I'll get the value of total discharge. So let's solve it. Yeah, 11,772 divided by bracket start. This is 9.81 into 0.86 into 380 bracket close. Answer. Yeah, this we got here 3.67. So 3.672, 3.6719 given. Let I will take 2. This much meter cube per second. This is our overall discharge or total discharge we can say. So now, as I told you, the formula required for us to find out the number of jet required. So we can write the number of jets equal to total discharge. Total discharge equal to 3.672 divided by discharge of single jet, that is 1.818. We'll get something value of 2, near about 2 will get. So this one divided by 1.818, 2.019. So here we got, this is 2.019. So this is nothing but I can consider number of jet is 2 jets. Okay, so number of jet is 2 jet. This is our third answer. This is the first one, first answer. This is the second answer, and this is the third answer, you can say. Anyway, so all these things we have calculated by using these formulas. So first of all, we need to understand what kind of question is given and what we need to find out from this question, and what are the formula will be used on this. Based on that, we can solve the problem. So I hope you understand this problem. Still, if you are having any query and doubt regarding this, you can give a comment on the comment box. Thank you.